This is properties of logarithms. This is properties of logarithms. So we are looking at three basic properties. We have the product property. And when we say that, we mean you have the word log, there's the base, and then the product is right here. It's inside the log, right? So this is the logarithm of AB. And what happens is you can rewrite this as two different logs and separate it with an addition. So the example here, you have log base 2 of 5x. So 5x is like the a and b. A is the 5, b is the x. And you rewrite it as two separate logs separated by addition. So you have written log base 2 5x. And by the way, the base has no bearing on the property. Okay, the base has no effect on the property. So you just rewrite it as log 5 plus log x. Right? If here's the quotient property, if you have a fraction or a quotient, you can write it as subtraction instead. So this log base 5 of 12 sevenths turns into log base 5 of 12 minus log base 5 of 7. Right? Again, the base itself has no bearing on it. And every once in a while you see where I just don't even bother to write the base. Okay. Here, and with the power property, so there's all kinds of things going on here. So you have a base of the log, and then you have the thing inside the log, the argument. And this argument is made up of a base itself and its exponent. So this exponent is going to come forward and turn into a coefficient. So here I have, so this is log base 3. 6 is the base of this exponent of 4. That 4 is going to come forward and become a multiplier. So it's 4 times the log base 3 of 6. So the exponent that was up here has moved forward and become a coefficient. So that's what it is. All right, so let's do several examples here. So you're going to apply the rules of logarithm here. So we're going to be given the left side and we're going to separate it out into these other properties. All right, so here in the first example, and then you go, well, there's no square roots up here. You're right, there is no square roots up here. However, recall, not too long ago, if you had a square root, you can rewrite it as an exponent. So this is the same thing as log base 6 of 17 to the 1/2 power. So I rewrote it, the square root, as an exponent of 1/2. So now I'm going to use the power property and move the 1/2 forward. So that's going to be 1/2 log base 6 of 17. That's it. So same thing with example B. That's cube root, so that means I can rewrite it as an exponent of 1/3. And you move the 1/3 forward. So that's going to be 1/3 log base 2 of 5. All right, that's it. All I did was take that exponent, move it forward, and make it a multiplier. Technically, you can move it afterwards, but it's confusing. So don't write it like after the log, because then the question becomes, is it 5 times 1/3 or is it log base 2 of 5 times 1/3? If you put it in the front, there is no question. It's not, you're not multiplying 5 and 1/3. You're multiplying the log of 5 times the 1/3. All right, so here is multiplication. Remember, multiplication, that's the a times b, can be rewritten as addition. So this is going to be log base 4 of a plus log base 4 of b plus log base 4 of c. All right, so you might ask, why are we bothering to do this? Well, addition is actually easier than multiplication, so that will be a reason to change multiplication into addition. All right, D. And later on in calculus, this is a more useful form than that one is. Right, the product is much more complicated than the sum. All right, let's take this one. We have a product and you have an exponent. So first thing I'm going to do is just rewrite it as sum. So I'm going to write that as a sum. So log base 5 of 7 plus log base 5 of 12 to the 3rd power. Now I can rewrite that exponent of 3 as a coefficient. So it's going to be log base 5 of 7 plus, and I'm going to bring it forward as a coefficient. So it's 3 log base 5 of 12. And that's it. So another question might be, when do you stop? How do you know you can stop? You can stop when you have one number, one expression, one small expression inside the log. Okay. All right. In other words, there's no exponent, there's not a product. Now you might argue, well, 12 can be written as 3 times 4. Okay, I'm not asking you to go that far. You don't have to break it down further. Okay. 12 is further. As long as it's just one number, that's fine. Okay. All right. E. Here you have power and a fraction. So we're going to first split up the fraction. So it's going to be log base 3 of x to the 6 minus log base 3 of y. So I have this exponent now. I'm going to bring the exponent forward. So it's 6 log 3 of x minus log base 3 of y. And that's it. All right. And that's the answer. Let's go on to F. Here, it's probably easier to just rewrite this mess as one nice exponent. I'm going to write it as 11 to the 2/3. Okay. And then we just bring down the exponent. So it's 2/3 log base 3 of 11. Next one. So here, you can do this several different ways. I'm going to do it kind of a long way. So I'm going to deal with this exponent of 2 first. So I'm going to bring the 2 forward. So that's going to be 2 times the log of, and then it still has this fraction. Now let's rewrite that fraction. So that fraction, and I'm going to put, now it's probably technically should be parentheses, but I'm putting square brackets for emphasis. So that I'm multiplying 2 times whatever comes out. So that's going to be log base 7. Oops, I forgot the base. So it's log base 6 of 7 minus log base 6 of 10 to the 4th. All right, so you got one more thing left. Sorry, right? There's 2 numbers here. There's a 10 and a 4, and 4 is the next one. So I'm going to move the 4 forward. So that's an equal sign. 2 times, and now changing it to parentheses because I forgot what I was doing. Log base 6 of 10. All right, and you're fine to leave it like that. If you want to multiply through by 2, that's fine. And if you did it a different way, you might have the version where it's already multiplied by 2. Okay, what's a different version? Well, you could have just distributed that 2 to begin with, making it 7 squared and then 10 to the 8th, right? And then do the properties of log. So that would have been perfectly legit. All right, but I didn't do any of the other properties first. All right, move on to H. So here, this is c to the 3rd times the square root of ab. So let's split that up first. So that's going to be log base 9 of c to the 3rd plus log base 9 of square root of ab. I'm going to go ahead and write ab to the 1/2. All right, because remember square root can be written as an exponent of 1/2. Now, oops, let's bring that exponent down. That's 3 log base 9 of c. Bring down that exponent, so it's 1/2. Ooh, it's a plus sign, not an equal sign. Half log base 9 of ab. Now I still have to split that up. So it's 3 log base 9 of c plus 1/2 log base 9 of a. And remember, this 1/2 has to multiply everything that comes out, so it's going to be plus 1/2 log base 9 of b. And there's my final answer. Right? Okay, moving on. So this is in example 2. We're doing this backwards. So up here, the directions are to expand the logarithms, right? Expand the logarithm. So we had properties of log here, and we expanded, right? And when we say expand, we want basically just one thing inside the logarithm. Now here, this is the expanded form, or at least, okay. And now we're going to put it into condensed form. Condensed form means like basically you just have a log and everything is inside that one log. So here you just have a 2 sticking out. So you're going to put this 2 back in, and we're going to use that property where, remember we had the power rule, power property, right? So this time we have the right-hand side of this equation. So we're going to take that coefficient and make it an exponent. So we have a coefficient of 2, and we're going to make an exponent. So it's log base 8 of x to the 2nd power. And then b. So I'm going to take that exponent first. So I'm not doing anything with the first part. And I'm making that y squared. Now, it's a plus sign, so I can write it as a product. So it's going to be log base 5 of xy squared. And that's it. Continuing, c. All right, c. All right. All right, so here we have this coefficient. It's going to become an exponent, and same with this one. So that's going to be log base 3 of 8 to the 6th power minus log base 3 of 7 to the 5th power. All right, I haven't been saying much about the base. As long as they're the same, you're safe, right? Nothing special. Now, it doesn't affect the way you do it, the problem. All right? So now we have a minus sign, so that means I'm going to rewrite that as a fraction. So it's log base 3 of 8 to the 6 over 7 to the 5th. That's it. D. All right, so here I have the 1/2. I'm going to move it to as an exponent. So it's log base 8 of 10 plus log base 8 of 7 to the half. And you could just write that as a square root. And there's a plus sign, so that means you're going to write it as a product. So it's log base 8 of 10. And remember, 7 to the half is the same as square root of 7. And there's my final answer there. B. Some of you might say, oh, do I have to do that? Well, no, I guess not. So technically, this is also correct. We can just leave it as 7 to the half. All right. E. Now, some of you are like, what is this? Is this IN? No, this is LN. LN stands for natural logarithm. Natural logarithm is log base E, right? So it could be written as log base E. So this could be 2 log base E of 6. But we'll just write LN, short for natural logarithm. So yeah, just write natural log. I'm going to say log. I'm going to say 2 log 6, 3 log 7, 8 log 3. But it's 2 times the natural log of 6 minus 3 times the natural log of 7. Okay, so use the same properties. So 2 becomes an exponent. So it's natural log of 6 squared minus natural log of 7 to the 3rd minus natural log of 3 to the 8th. Now, you have multiple negatives and you have one positive. And the question becomes, how does that look as a fraction? So here's the rule. If it has a negative in it, it's going to live in the denominator. If it doesn't have a negative, like this one, it lives in the numerator. So you're not going to have like 2 different denominators. You're just going to put it all into one denominator. So this is going to look like natural log of 6 squared, right? That one was positive, so it's in the numerator. Both of these are negative, so they're both in the denominator. So you write 7 to the 3rd, 3 to the 8th. And that's a perfectly legitimate answer, okay? That's all that. That's all of that is live inside of this natural log. And last example. So we have this. So the only exponent we have to deal with is 1/2. So let's move that over. So it's natural log of 5 plus natural log of x to the half. Oh, notice there's another coefficient. So there's minus natural log of 7 squared. So this time you have 2 of them are positive. So the positive one's going to live in the numerator. So it's 5, and that's a 1 x to the 1/2. So that's square root of x. And then you have the 1 negative, so that's going to live in the denominator, 7 squared. And that's the final answer. And that's the last example.